This is called direct substitution. So when you take the 3 and plug it directly into your equation and get the result, that is called direct substitution. So there's actually a really cool process. It's called synthetic, which works for evaluating functions. And it turns out it's actually really good for dividing as well, which is kind of interesting. So we're talking about some very interesting theorems today. I'm not a big theorem person. I don't like theorems. I think they make math hard. But you guys are those people, so you'll see them written down, but I'm not going to talk about them. All right. This is called direct substitution, plugging in directly and evaluating. But I'm going to show you another way, which is using synthetic. It's called synthetic division, but it goes both ways. It's another way to substitute in value. Okay. You'll notice this is the same polynomial. And the directions say find f of c by evaluating directly, which is what you just did. So we already did part A. And then using synthetic division. So I'm going to show you this synthetic division thing. Okay. Now it's called synthetic division. And what I'm going to do is I'm going to create a little division box. I don't use the same symbol as long division. Most teachers use this sort of little box thing. The number that we want to evaluate, the number we're going to plug in, essentially, is goes on the outside. And we get to write along the top. We get to write all the coefficients. It's kind of nice. We're going to put down the 2. That represents 2x cubed. We're going to write down the 1. That's just going to represent 1x squared for us. Negative 6 is going to represent negative 6x. And then negative 9. One thing that's really important when we do this synthetic division is that we have all of our terms accounted for. Meaning we're going x cubed, x squared, x to the first, and then x to the 0. What's x to the 0? 1. Okay, so we don't write that. But we have all of those accounted for. So if it's x third, there are always going to be 4 terms or 4 columns, if you will. If it was x to the 5th power, then you should have 6 of these numbers along top. Okay? All right, so make sure everything is accounted for. We'll do one where it's not. Now, all right, here's the very magical process. It's super easy. The whole process is combine, multiply.
What?
Combine, multiply. That's it. So I start with the 2, and I combine it with what's underneath. What's underneath it? 0. And that gives me 2. Combine. I don't ask why. Don't ask why.
Just look. No, 0. Just look.
There's nothing there.
No, like, what is it, like a fraction? Is that what we go underneath?
Could there be something?
There will never be anything there.
What are we adding?
So, like I said, don't try to understand, just go with it. Okay, so then we're going to multiply. 2 times 3.
6.
6 goes in the next column.
Whoa, that's 6 times 3?
And then we combine.
Oh, no. Ding it.
6 and 1?
7.
7. 7 times 3. 21. Combine.
15.
Yeah.
15.
Okay. 45. Ooh.
45. Combine.
36. Oh my.
Oh my goodness.
Magic.
What was f of 3?
36.
36. Look at that.
Why didn't you show us this last look?
Whoa.
Mathematicians need to be on to, like, get that.
Don't ask. You don't want to know. It's arithmetic. It's
Such an ugly word.
but it gets weird. This gets really weird.
I'm just trying to understand how
So it's just the coefficient. the 2, the 1, the negative 6, and the 9.
Wait, then why do we have to
Just
show
the focus.
start A and B?
Okay. Okay. Quiet. That's not all, ladies and gentlemen.
You have to add up all the bottom.
So not only did we just do synthetic substitution, okay, we substituted a value in. And it turns out that this last number happens to agree with what we did before, right? Okay. That's not the only thing. All right, we actually just divided. We just divided, and it turns out that this number is the remainder of, hold on, wait for it. That last number is always the remainder in division if what we had done was 2x cubed plus x squared minus 6x minus 9 divided by x minus c. So x minus 3. If we divided our polynomial by x minus 3, it turns out that we get this quotient plus the remainder. All right, this is a quotient. 2 and 7, I know, don't try to understand. It's craziness.
So we don't have to complete
Yeah. Okay. So this is actually the quotient. It looks like just numbers, but it actually represents a polynomial. So what we did was we took our original polynomial 2x cubed plus 1x squared minus 6x minus 9, and we divided by x minus 3. We're dividing out an x. So if we started with 2x cubed and then we divide out an x, we're left with 2x's squared. And this is a 7x. And this is just a 15. So we get 2x squared plus 7x plus 15 plus the remainder of 36 over the divisor x minus 3. Interesting. Remainder over divisor. Totally crazy. Totally crazy. So
that's the answer, not 36.
no, they wanted you to see that you can plug in directly and get 36, or you can use synthetic and also see the 36. Okay. So here's the remainder theorem. The remainder theorem says if the polynomial f of x is divided by x minus c, there's our x minus c, then the remainder is equal to simply just plugging it in. Totally weird. It's totally weird.
But it makes sense.
Well, that's good. Your book talks all through it and it tells you why it works. Your book is really great like that, but I'm not about that. I'm more like, okay, let's just do some more. All right, so let's try another one. So they want you to do A and B. Yeah, they want you to do that's part A, and then they want you to do the synthetic to get the same remainder, just to see it both ways. So let's try another one. We have a polynomial, 6x to the 5th minus 3x cubed plus 2. And we want to find f of negative 1. So there were two methods they wanted us to use. They wanted us to evaluate directly. So f of negative 1 means what?
Negative
Plugging 1 for all the x's.
Negative 1 goes in place of all the x's. Well, we can do that. You can use calculators and you can figure it out and answer pretty easily. So go ahead and do that. Go ahead, do it. Do it now. Make sure you know how to use your calculator. Carrot. Oh,
Oh, it is minus one.
the carrot.
Oh, very good. I was just waiting on everybody else.
-1, right?
Yeah. How did I get a lemon for this other way? Just do it in math. Math just doesn't make sense eating my ass right now.
Because of that. All right, what'd you get? -1 is the correct answer. Now you need to figure out how to get it right.
That is -1.
So in case you were curious about your calculators, this little symbol, I call it a carrot.
Oh, I forgot about that.
Okay, the carrot is how you power things up.
Right.
Okay. All right. Okay, so it should be -1. Now using synthetic,
You get two different answers.
you shouldn't get two different answers.
What did you do?
So using synthetic, we have to fill in our missing terms. Do we have all our powers of x accounted for? No, there are missing terms. So we need to fill in those missing values, missing terms. Meaning I have 6x to the 5th. What's missing? 0x to the 4th. Then we have -3x cubed. And then what's missing? 0x squared. What's missing?
0x.
0x.
2.
And then the 2. Okay? If you have holes, you have to fill them in. Synthetic substitution or synthetic division will not work with missing terms. Okay? So, all right, we're going to put our value on the outside. And now I get to write all the coefficients along the top. So this is a 5th degree function. There's going to be six columns here that we're going to go through. 6, 0, -3, 0, 0, 2. Okay? There's something to do with this compounding on itself every time you add and multiply and move to the next column, which is how it kind of works. All right, so 0 plus nothing is, 6 plus nothing is 6. And then we multiply 6 times -1, -6. Combine, multiply, combine,
Yeah.
multiply, combine, multiply, combine, multiply,
Oh my God.
-1.
-1.
All right, totally crazy. -1 is the remainder. It also happens to be the value when you plug in -1. We get the output of -1. It's a point on the graph. It's totally crazy. I know. I don't know. It's totally ridiculous.
I don't think they were sober while they were doing it. Oh no, they were definitely on some form of.
So let me ask you a question. This thing represents our quotient. And I want to convert that quotient back into a polynomial. What would that polynomial be?
6x to the 5th minus 6.
No.
I mean the 4th.
Oh, there we go. 6x to the 4th minus
6x
6x cubed plus 3x squared minus 3x plus 3. So there's our quotient in the polynomial form. Okay?
Okay, do you get it?
Yeah.
So yes, that's what we're doing. Okay. If you wanted to write the plus the remainder over, what's the divisor? What did we divide by? X minus the -1, which is really x plus 1.
Yeah.
Okay. Good. All right. Okay. So we call this synthetic substitution. In some books, like it's a whole section in and of itself. They just teach you synthetic substitution as a way to evaluate polynomials. It's really fast. Like it goes really fast. And for complicated polynomials, it can be a lot easier than actually plugging in. Jacob.
So, do we have to put out the equation, or do we just need to get the remainder?
So no, so for the first section, it's just the remainder, but the bulk of your problems are not this.
Oh.
Okay, this was me just teaching you the synthetic process.
Oh.
Okay.
Okay.
Yeah, so this is not what we're doing.
Paying attention, bro.
Okay. All right, so this was me just teaching you how to do synthetic, okay? And showing you that that remainder also happens to be what you get when you evaluate the function, which is crazy, okay? It's the remainder, but we can also use that information to determine if something is a okay? Yes, no, sir, you're wrong. I give you everything. Okay. All right. So example 2, is it a factor? Now, what we've been doing a lot of in this class is factoring. Okay? We take a polynomial and we double bubble. That's factoring. Well, factoring is really useful. And it turns out in this chapter, which is this polynomial chapter, is really, really important. Then we want to be able to factor things. Because it turns out when we can factor, we know a lot about the graph. You guys have done a little bit of graphing. But if I have a number like 56, and I were to divide it by 7, what would you get? 8. Remainder?
8.
0.
0.
Remainder 0. Okay? Now, because it has a remainder of 0, we can say that 7 and 8 are factors.
Oh.
Okay? Because if you divide 56 by 7, you get a remainder of 0. 8, remainder 0. If you divide 56 by 8, it goes in 7 times, remainder 0. Those remainders of 0 mean they divide evenly. And because they go in evenly, those are factors. Okay? Factors always have a remainder equal to 0. Okay? So in order to know if something is a factor, then we can use our synthetic division to help us figure out if it's a factor. Okay?
You just for this specific problem, you just tell just a lot.
Wouldn't I know because why? All right, so what I'm going to do is I want to divide this polynomial by x plus 2. And if it divides evenly, meaning if it has a remainder of 0, then I'll be able to tell that it's a factor. Okay. Now, if I want to divide by x plus 2, what would I use on the outside of my box? Negative 2. Very good.
Why negative? Why don't have to Why negative?
All right. Because x equals negative 2.
Oh, really?
Yes, that's right.
How do we know? Subtracting 2 where? Subtracting where?
All right. So yeah, I call this the factor of x plus 2. The number that goes on the outside is always the solution. So if you have the equation like x plus 2 equals 0, and then you would subtract 2 to get x by itself, that's the number that goes on the outside. Okay? So then I have my 5x cubed, my 8x squared, my negative 1, and my 7 along the top. And we can do our little synthetic. 5 plus nothing is 5. Multiply, we get negative 10. Negative 2. 4.
3.
Negative 6. 1.
Well, no.
Remainder 1. Is it a factor?
No.
No. X plus 2 is not a factor. And we could have shown that another way as well. We could have just plugged in negative 2 and evaluate it, and again, whatever it equals is the remainder. Okay, so that's the remainder theorem. And so there's two ways to do that. So we could, I like the division method because I think it's super fast. So because it's not a remainder of 0. In order to be a factor, it should have a remainder of 0. Okay? All right, let's try another one. Or it's similar. This is what we really need to know in life. This is the goal. Use synthetic division to show that g of x is a factor. Then complete the factorization. Our goal is always to factor polynomials. We want everything in bubbles. And sometimes we can write all those bubbles by hand, and sometimes we can't. And when we can't, we have to use things like synthetic division to help us out. So use synthetic division to show g of x is a factor. What does it mean to be a factor?
No remainder. Remainder equals 0.
Remainder equals 0. Good. Remainder equals 0. So we can do some division. Okay. So we're going to take our polynomial. It doesn't have any missing terms in it. And what am I dividing it by? X plus 7. What goes on the outside of my box? Yeah, x equals negative 7 goes on the outside. Good. 1, x cubed, 3, x squared, negative 25, and 21 goes along the top, which comes directly from my polynomial there that I'm trying to factor. All right, I'm going to 1 and 0 makes 1. We're going to multiply. 1 times negative 7. Combine. Multiply. Combine. Multiply. Remainder 0. Okay. Which means I can write my polynomial f of x is now, for instance, if I take 56 and I divide it by 7, what do we get? 8, remainder 0. And then I can take that and now I can say, hey, 56 is really 7 times 8. Okay, so what we want to do is we want to rewrite what we started with as the product of two things. What did we just divide by? X plus 7. That's what we divided right there, the divisor. I guess I'll give you the word, D-I-V-I-S-O-R, divisor. And then times the quotient. Very good. So again, this is the quotient, and we want to convert it back into a polynomial. So what would it be? 1x squared minus 4x plus 3. Very good.
Wow.
All right. So notice, if you were to multiply these two things together, what would we get? The same thing we started with. Okay. Now, we want the complete factorization. So this leftover bit here, we can actually double bubble again. And this is our goal. Everything today, you will factor more. What times what is x squared?
Negative 3 and negative 1.
Oh, well, yes, you're ahead of me. You're ahead of me. Yeah, that's good. All right. Last times last is positive 3, so that's going to be negative 3 and negative 1.
Okay.
This is the complete factorization. All right, complete factorization. Lots of bubbles, ladies and gentlemen, lots of bubbles. Okay? Do you have any questions on that?
No. Is this all today?
That's it. Yeah.
Okay, this is great.
Wow! Is it gonna get harder?
All right.
Yes.
You're doing damn well.
If you can do this, we just did 2 sections in one, ladies and gentlemen. So
Oh, yeah.
yeah,
Oh, I feel like.
yeah. So if you can do this, then you're great.